For launch. We are go on all LCCs and expected to remain go through the count. Our temperature is currently 80 degrees, could climb to 82 by the end of the window. Winds are currently from 220, 8 knots sustained with peaks to 10 knots. 10% POV for the cumulus cloud rule. Proton flux is at normal background levels and expected
welcome
to remain
back
so through
to
the count.
another video.
Concludes the weather
So
brief unless there are any
today
questions.
we are going to be watching the NASA Perseverance launch
so
live
I think we're in good shape.
right here on this channel here. This is a miraculous event. It is an amazing event.
Remember the second C. Appreciate that. So,
I said that I was gonna do it at 7, but I couldn't because of times and issues and
two different clocks. The L
stuff
clock,
like
or what
that.
we call the launch time, or L minus time, is the real-time clock, which continues to count down towards liftoff.
We have T
T-time,
minus.
that's the clock that the team uses for operational sequences of events.
T
in the
minus
procedure.
28
this
minutes.
This time has built-in holds in it, one of which we're in right now, 30-minute hold, which allows the team to adjust things that they need to do
We have
throughout
T minus
the countdown
22
tonight. So the L clock will continue counting down.
minutes.
And what's unique about this is at L minus 4 or T minus 4 as we pick up the count, these two clocks will sync up and we will count down to liftoff this morning.
One of the things we want to kind of piggyback off of the weather briefing for is to talk about the power source for Perseverance. Perseverance actually has a nuclear battery, which that might be a little bit alarming for people to hear that. It's not a nuclear reactor, it's a nuclear battery, and it's
You guys would just have to watch
the Department of Energy for this kind of purpose. It's a multi-mission radioisotope thermoelectric generator,
real
which
quick
is a
and
mouthful,
listen to it.
but it's an MMRTG. It's roughly the size of a 5-gallon bucket, and it is designed to actually make. How does this actually produce power for the robot?
So it's using nuclear material inside, right, to generate the electricity that's there. Starting off the mission today, it'll be about 110 watts of power that provides the spacecraft as we lift off. And it'll provide power for Mars Perseverance throughout its whole mission life. So that's the unique thing about this battery source that's pretty neat, is that it will continue for the whole time.
Yeah, the Atlas V has a perfect launch record, so it's in good shape. So we're not expecting any problems, but if there were a contingency today, we'd want you to stay with us to talk through some of the details, and we'd be providing advisories. We have teams that have been focused on this specifically, and they're working towards making sure that everybody is safe, and our robotic explorers are safe as well. So that's going to do it for now. A great weather briefing. We'll send it back over to you, to Daryl and Moo.
Thanks, Joshua. With the countdown to Mars well underway, we want to take a moment to honor our country with the singing of America the Beautiful.
We are proud to present to you now two-time Grammy Award-winning singer Gregory Porter.
T minus 24 minutes and 10 seconds.
The beautiful baritone voice of Grammy Award-winning singer Gregory Porter. That was outstanding.
It was so emotional.
If
really
I could launch the rocket right now after that, see some rockets, red glare, it's perfect.
Yeah, that'd be funny.
Appreciate that. So, Perseverance will seek
If somebody was singing the Star-Spangled Banner.
Scientific instruments can only go so far.
And then
joining us now to talk about returning
and then
Mars
it
samples
launches
back to
at the
Earth
correct
is
time.
Dr. Lori Glaze, Director
I forget
of
what
NASA's
it's
Planetary
called.
Science Division. Thank you so much for joining us today.
It's my pleasure. Happy to be here.
Yeah. First, can you talk to us about the value of studying Mars samples here on Earth?
You bet. So one of the most exciting parts of this mission, of course, is that we're going to drill samples that we're going to go back to Mars and pick up and bring back to Earth. And part of the reason for that is, or the main reason is, that we can only go so far with the instruments that we have on the rover. They're wonderful, it's a great suite, but nothing compared to the state-of-the-art instruments in the laboratories around the world. So we really want to get those precious samples back here so that we can do that really in-depth analysis of the samples here.
Could they just launch a lab over there with humans in there?
With those state-of-the-art instruments and facilities, we can preserve actually most of the sample for decades, and that will allow us to use future instruments that haven't even been invented yet, or answer questions we haven't even thought of.
Look
yet.
at those
so
clouds
it's
back
really
there.
important to get those samples back here.
And could we confirm life if it is there with
when it's
the
still
instruments we have
launched
on the rover, or would that actually happen back
That
on Earth?
is what
I fully
want
expect
to
we won't
see.
be able to make that real determination until they're back here on Earth. We expect with the instruments we have on board to be able to detect biosignatures and the types of things that say, yes, this is a sample that may contain evidence of past life in the sample, but I think it would be very difficult to confirm
7:50
that until we
a.m.
actually get
is
the samples
supposed
back here on
to
Earth.
Speaking of getting them back here to Earth, the key part of this, how will you do that?
That's a great question. We're already starting work on that next mission called Mars Sample Return. We think it's going to launch. We're planning for a launch in 2026. This is a really complex mission. It's going to require 2 launches from Earth and 1 launch from Mars in order to get those samples back here.
Wow.
We're working really closely with the European Space Agency, our core partners on this mission.
Yeah, NASA and ESA
which will launch
are working on
sample
this
return lander that will
together.
land on the surface carrying a fetch rover that will go out and pick up the samples, bring them back, load them into a rocket, the Mars Ascent Vehicle, and launch them into orbit around Mars. At the same time, when we launched from Earth, the Europeans are also launching an orbiter from Earth that will be in orbit around Mars, and it will capture those samples with that orbiter. We're going to capture them, and then it will make its return trip back to Earth, release them, and they'll come down and land in the Utah desert, where we will then safely carry them and put them in the curation facility.
Wow, what a process.
Awesome.
Yeah.
That is so amazing. Thank you so much, Lori, for joining us today. We appreciate
My
your time.
pleasure.
Enjoy the launch. Get a
I'm
view.
gonna. Yeah, go Perseverance, go Ingenuity.
Awesome.
Thank you, Lori. Well, in the early 1900s, the Wright brothers proved powered flight was possible on Earth. Now, NASA plans to test a powered flight on Mars with an ingenious helicopter. So, let's get back out to California.
It is
now,
not
and Raquel,
genius, it's
the Martian atmosphere
ingenuity.
is 99% less dense than here on Earth, so this is no easy task to fly on Mars.
It is, Daryl. Now, hitching a ride on the Perseverance rover is an exciting technology demonstration. The Mars Ingenuity helicopter. Now, if successful, it would mark the first time humans have taken powered flight on another planet. Ingenuity's project manager, Mimi Ung, joins us now to talk about the set of milestones Ingenuity needs to hit in order to take flight on Mars.
T-minus 19 minutes and
but anyway,
45 seconds.
Mars helicopter tech demo is motivated by the potential of adding the aerial dimension to space exploration. In the future, a helicopter can serve as a scout for rovers and astronauts. A helicopter can get us to places of high scientific interest that cannot be reached today. It's not easy to build a rotorcraft for flight at Mars. The atmosphere there is very
It's
thin,
getting closer and
1%
closer.
compared to that at Earth.
Wish I could
So a
take the
helicopter for
NASA
Mars
symbol out
has to be very light and have
so
a
we
rotor
can actually
system
see
that
the
can
launch
spin very
time.
fast. Behind me is the full-scale model of Mars helicopter Ingenuity. It's very light, 1.8 kilograms, about 4 pounds. It's capable of flying through the thin atmosphere of Mars and is capable of surviving and operating autonomously. There is a set of milestones between now
Mimi
and Ingenuity's
finishes
first flight.
out
The very first
talk
one
about
is when we turn on the
some
helicopter
stuff
in
with
the base
this
station to check their health.
helicopter.
First time operating in true space environment. The next major milestone will be when Perseverance rover deploys Ingenuity helicopter to the surface. The deployment will also mark the first moment the helicopter starts to work on its own in a standalone manner. It will never return to the rover. And the first major milestone then will be the helicopter surviving the first cold Martian night, about minus 90 degrees Celsius. And we've designed the helicopter to keep itself warm. So we've planned for up to 5 flights in the 30 Martian days that have been set aside for our flight experiments.
Guys, make sure to go down below on this video. Make sure to hit that subscribe button, hit that red subscribe button, leave a like on this live stream, and hit the notification bell so you get notified
of
whenever
Martian
I
terrain
make
taken from
another
Aero Vantage.
video.
That would be true icing on our cake.
Cake, Mimi, thank you. And you're right, we did have a little bit of a shakeup, but everything seems to be okay right here so far. And we look forward to Ingenuity's first flight. And with that, let's head back to KSC as we continue the countdown to Mars.
All right, thank you, Raquel. When the name Perseverance was chosen for the rover, our country was in the early stages of the COVID-19 pandemic. Now, the name is also a fitting description of what NASA teams needed to get this rover to the pad on time. Joining us now is NASA Administrator.
Let's now mute the screen audio. So, but y'all, so there's like another little rover, not the rover that ESA is sending to send the launch. No, this one is. It isn't this one. It's something called Scarecrow. Scarecrow is a rover that is going to move near it. So it weighs, I don't know how much Scarecrow weighs because they haven't really been talking about it that much. So even though they are not seeing it that much, even though they are not seeing it that much, even though that it is that much, it's probably like around 4 pounds, same as like Ingenuity, maybe more like max 15 pounds, but nothing much. So due to that, it isn't a lot. That means that it would probably not, you could say, just make it that much. One second.
On the back end that things are proceeding well. No.
Okay, so the Scarecrow rover is going to weigh how much it does on Earth is what the Perseverance will weigh on Mars. And Perseverance is like 15,000 kilograms. Let me see that real quick. So Mars 2020 Perseverance Rover Wikipedia. So you guys can now listen to them.
So this should be coming
and then I'll look
right on
for
time here in just a few seconds. Let's listen in now.
This is the NLM on the NLM net. Currently working, no issues on the Ranger or the launch vehicle. Weather is green, 10% chance of violation, and winds aloft look good for the entire window. The spacecraft did experience some earthquake activity at their control center in Pasadena, but appears to be ready to proceed. And with that, I would like to poll the team for final launch poll and spacecraft configuration. NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA Mission Manager.
NASA Mission Manager is go.
LSP.
LSP is go.
Copy. NASA team is ready to proceed.
All right, so we heard NASA team is ready to proceed.
Good,
You
good.
even mentioned the weather
That's
in there,
good
which is
that
great.
they're,
Only a 10% chance of violation.
good to
Again, a big
proceed.
thank you to Jessica Williams of the U.S. Space Force 45th Space Wing.
I like the fact that we're working no issues this morning into this
We
count.
are
That's an important part that Omar
extremely
brought up.
happy that it
And,
is going
the team,
to launch.
one thing you need to understand about
And
the
this
NLM is it's
is
a combined
a
NASA team of
miraculous
spacecraft
event,
and engineering.
kind of like
so
whenever
hearing
NASA
all those goes is
launched
good this morning.
Yep,
people
and we're
in
going to
the
keep moving because we got a lot
SpaceX
to do still.
launch.
We're going to throw it back out to you, Daryl.
Speaking about NASA and SpaceX, we will be talking about Isaias at the end of this live stream.
We are
But
about to
after
hear from
launch,
workers at centers in California and Florida who took
so
every imaginable
T-minus
precaution
10
while
minutes,
managing to get this
T-minus
vital work done.
10 minutes.
When I saw the country shutting down, I thought for sure there is no way we're going to be able to continue this.
It's something that nobody expected. It's something nobody could
Well,
plan for. Rather than
actually,
your
I
first
cannot
priority
find
being
it.
mission success
So,
and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
I was seriously thinking Mars would be Mars 2022.
if it doesn't happen today, it will
It's like a
happen
lot of work to
tomorrow, I
put stuff
believe, at
together in
the
order
exact
to
same time at
events going, to
7:50
keep people working safely,
a.m.
keep them healthy, and to
at
keep the project,
7:50 a.m.
on schedule.
There's no doubt
EST.
that working in
It's supposed to
isolation,
launch.
not
This is
virtual
NASA
isolation, but
plus
in
ESA.
physical
Due
isolation
to
from
that,
everyone else
NASA
is a challenge.
It's hard for me. I have
is
two young kids. Sometimes I'm
supposed
not able
to,
to focus
really,
or
you
listen
could say,
probably as well as I want to.
they're
A lot of our
supposed to
work was occurring in a
retrieve
clean room anyways,
all the
but that meant
samples
that even before
while
we entered the clean
NASA
room, we had to
like
find ways
builds all the main
of
stuff
ensuring
as an
that,
Ingenuity,
we were not putting ourselves or
Rover,
others at risk.
Perseverance, Scarecrow, and
Most of the time
all of
for these
those.
missions, our relation with the
So-
spacecraft customer is incredibly important. So usually we're able to be here working beside them on
Yeah.
their equipment and making sure that all of their needs are covered even before they ask for it. It is a challenge, but we're used to meeting unique requirements here at the hangar, and we pride ourselves in our flexibility.
This is just another mission, just with a different set of obstacles that we have to overcome. It might not be, like a broken rocket, but it's it's got its own challenges.
Our job is to go into the unknown. And this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 Perseverance plate that's now affixed to the port side of the rover. It has a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way
That's
to Mars,
cool.
and all of this supported
That's
by a now
really
familiar
cool.
staff and
Do
circuit
really
of
have
the
to
medical
admit, that
community.
is
And we hope that this
cool
mission,
looking.
in some small way, can inspire them in return.
Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which you could not have come up with a better name than Perseverance.
We have persevered through this. Nobody's given up. We will get this mission done. We will get it done through the pandemic.
If it doesn't,
now
well,
it's a really important symbol of humanity, hopefully persevering through this
due
great
to
challenging time that we have
Isaias,
We appreciate that team as well as the
being
medical
right
community that
near
really
the
stepped up
launch
and helped.
site.
And it's ironic,
If
Lou,
it
because
doesn't
the name
happen in the
Perseverance was
next
chosen by a
like
second
3,
grader
4,
at the
5
time
days,
he submitted that name.
if it keeps
He didn't
failing
know that we would be
weather-wise
faced
or
with a global
mechanical
pandemic.
wise,
So
they'll have
we
to
are
wait
glad
like
to
a
have him and
week
his
or
family
so
here, along with the
for
student who named the
Isaias.
helicopter, to watch the launch in person.
Their names are Alexander Mather and Vanessa Rupani, and they are watching from the 5th floor balcony of our engineering building, just a stone's throw away from the countdown clock. Look at that, there they are,
There they
looking
are.
cool.
Yeah, Tropical Storm
Alexander Mather, who
Isaias
goes to Lake
has
Braddock
flown.
Element Secondary
And
School
it could
in
be
Burke,
a
Virginia,
ball
submitted
game.
the winning essay to name
And it's
our
actually
rover
forecasted.
Perseverance.
Yeah, they've got a
Looking
great view.
like
I've
to
seen it from up
possibly
there. They've
now
got the
skim
VAB
off
in
of the coast
background,
of
as you can
Florida,
see there. So
but
it's
go
such a
really
beautiful setup
close
for this awesome launch.
and
Vanessa,
where
you can see her.
this launch site is around 2 a.m. on Sunday, which could make them pause or wait or don't do
She
it.
entered the contest as well
But
and came up with
is
the name
actually forecasted to
Ingenuity
hit the
for our
outer banks.
helicopter
Of
that will
course,
accompany
all these
our rover
models
to
could
Mars.
shift
Thank you both
right
for
or
being
shift
here.
left.
What a neat
If
view
it
that
shifts
is.
left, then it'll be
All right,
like
folks, with the coast phase
nicking
coming up,
all
we wanna
of
let
the
you know that
islands
after the launch,
on
it
Florida,
will be about
Georgia,
an
South
hour
Carolina,
before
North
Mars
Carolina,
Perseverance
and then it'll
separates
probably
from
just go
the
straight
second
up
stage. When
into
that
North
happens,
Carolina.
the rover will then be on its way to Mars, so hang in there.
Yeah, don't go away as we will walk you through the flight around the Earth, and we'll talk live with the astronaut Zena Cardman about our human exploration ambitions and NASA's Associate Administrator of Science, Dr.
The
Thomas
next
Zurbuchen.
advisory
It's
is
gonna
at
be great,
8
folks, so
a.m.
stick around.
AST.
It's L-6
soon.
minutes and 26 seconds now. And time to focus our attention on the launch
Wow,
operation
6
the rest of
minutes.
the way. to
Time
liftoff.
flies
So let's
whenever
send it
you're
back
having
out
a great
to
time.
Nick Altman and Joshua Santorin. Gentlemen.
Thank you. I want to let you listen into the remainder of this poll in motion. Let's go to that now.
Range coordinator. Clear to proceed. Launch director. LD is go, and you have permission to launch. Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
Good to launch. Sorry about the dog.
So 11:50.
Really sorry about the dog.
That is 7:50 a.m.
a.m.
Eastern
Yes.
time. So that time is correct.
As I'm watching Josh do the
Yeah.
calculations on his finger there.
Get my advocates out.
That's right.
No. So there's a lot to come ahead. One of the things coming up in just a few seconds.
5 minutes, 30 seconds.
OSC,
NSC.
go NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS, start list data capture.
Roger.
Yo, it's about
Fantastic.
to launch
Prior to
in
terminal
5
count. Switch
minutes. 5
Awesome. So
minutes.
things are really starting to pick up here. You're going to hear
Yes.
more and more chatter
Sorry
on
about
those
my
nets there.
dog.
That call
He
was to
barks
say that
whenever he
Perseverance is
sees,
powered
like,
and
a
ready to
squirrel
go,
or
which is a phenomenal call.
anything
Yeah, a couple
weird.
things happened
But
during
y'all,
that time.
it
Right?
is
The
about
launch
to launch.
conductor, ULA's
T
launch conductor,
minus
Scott Barney, pulled the
4
whole ULA
minutes
team. They were
and
all go. We got to hear
The third of our
55
5 teams.
the third of our 5
seconds.
teams. We got to hear the end of that where the range was clear to proceed, and ULA's launch director Bill Cullen gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are
The fourth team
that they are on internal power and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things
Straight
are looking good for us,
7:50
Joshua,
a.m.?
this morning. It's so, we talk about being nervous and excited. This is right here where we're nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to
Well, I
the
have the
liftoff this
exact
morning. We have about
time right
15
here,
seconds
so
left in this hole
we can
before
have the
pick up
exact
count.
time when
Yeah, we're going to
liftoff.
listen into that. The fifth team, the one we haven't mentioned yet, is the
T
Department of
minus
Energy,
4
who is
minutes,
responsible
about
for
4
the
minutes.
MMRTG, the
4 and a
power
half
source for
minutes.
Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, the teams are very disciplined, very focused
T
on what they're
minus
doing, the operational
3
sequence of
minutes.
events that they're following.
T
They're making
minus
sure
3
everything
minutes.
happens, especially in this T minus 4 and counting period, because there's a lot of things they have to
T
do. They have to
minus
finish
3 and
topping
counting.
the vehicle, make sure
Excuse
that all
me.
the tanks, first stage, second
You
stage,
cannot
and
math.
Centaur are at flight
I
pressures
can.
and full of fuel, ready to go for this morning.
But
They have to
T
make sure the
minus
FPS
3
system is
minutes,
armed
y'all.
and ready for
It's
personnel
getting
safety
closer
just in
and
case, so that the range
closer.
can do that. They have to check the electrical and avionics systems. They have to make sure that the
All
flight
of us
computer
are
has
like
all the information it
crossing our
needs to
fingers
place
like,
Mark 2020
please
into
make this
orbit
launch.
as to. So a lot of things going
my
on.
gosh.
Exciting time for the team right now. But again, staying focused and following that procedure they've got.
As we look ahead to post-liftoff, I want to kind of preview for you what's going to happen because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into
T
fairing
minus 2
separation,
minutes.
booster separation, and then the first main engine ignition
Yeah,
of the
let's
Centaur
get
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show. There's a ton more content we have to bring you, and we are far from over. Want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
Whenever, okay, so I'm going to live stream for this launch, and then whenever it goes into the cruise phase, which is T plus 50 minutes.
1 minute 55.
T plus 50 minutes. So after we do the T plus 50 minutes, and whenever it goes into its cruise phase all the way on to Mars, I will be doing it whenever it is landing too in February, on February 18th, 2021.
We're getting ready to turn the vehicle over to auto.
Don't know what time, but I will be doing a live stream. I hope.
Big thing that they're getting done here at T minus 25 seconds. We will hear the team give their final goes that everything is ready and the launch vehicle is ready to lift off and perform this mission.
SCS count started.
1 minute 15.
Produce ECS for launch. Roger.
1 minute.
1 minute 10.
Wait, 1 minute 10.
Lock.
Oh yeah. Wait.
1 minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right there.
Public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail.
7:50 should be launching now.
Yes, that's an important point. The reason we don't see that venting is
40
the
seconds.
has been locked up to put
Yeah,
flight pressure
well,
into the tanks.
7:50,
And as we just
40
heard, they're stable at
launch.
step 3, which means the tanks are ready to go. And here at about 5 seconds, we will hear the team
ECS reduced for launch.
Give their final go.
25 seconds.
Status check. Go Atlas.
Go Centaur.
Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5, 4. Engine ignition. 2, 1, 0. Release and liftoff.
43.
As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
It launched.
And Atlas TU has gone to closed loop control.
You're gonna have the speed or all that shebang, NASA?
Coming up on 30 seconds into
Yep,
flight, the
down there.
RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure.
It launched! That's amazing. That looks like an olden time screen.
And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector
If
pressures
you
responding
are
well to
happy
demands
that
on the
this
engine.
rocket launched, leave a
Standing by
comment
for SRB burnout shortly.
and leave a like. And if you aren't subscribed to this channel and or the Random News Space Center, go and
we have
subscribe
burnout
to
on
both
all
of
4
those,
SRBs. Burnout pressure
because
signatures look good.
this
Standing by for
video
SRB jettison shortly.
or afterwards this video will be on, or this live stream will be on Random News Space Center.
And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance.
Now you guys can just listen in.
Vehicle body rates are responding nominally at this time. And
And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we have the Mach 1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. It's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TGRS compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team. And we talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback, the Atlas is the quarterback's arm, Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically, you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars, because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months, right?
Tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually. Yeah. 25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now. And while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now. To recap, an Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is, and we're so excited about that as well. And while we wait for that second burn, hang in there with us because we got a lot of exciting coverage to go. We're going to welcome in one of our launch guests, Dr. Derek Muller. He is the creator and host of the popular science education channel on YouTube called Veritasium. He also holds a doctorate in physics education, so he's really smart. And that's why you saw us kind of having some fun, because Derek was here on set. We're just having a good time talking about this launch, which I got to start off with that, Derek. Your first time seeing a launch in person, what'd you think?
I mean, what can you say? That I have nothing to compare it to, but it was awesome, something I will never forget, and I definitely want to be invited back. So if you guys can make that happen, I mean, just so amazing.
You did a great job explaining physics. What did it feel like? Kind of walk me through as you were watching and experiencing it.
Well, it's like all the physics goes out the window a little bit. It's a very visceral moment between you and this very powerful craft. I think it's just amazing, all the, the engineering that goes into making something that's that powerful and yet that controlled,
Yeah.
And to witness that is phenomenal. And then to feel the rumble of all that sound as it hits you, I found it an incredibly emotional experience. It's almost unbelievable to, see it taking off. It's very surreal, that's for sure.
Nice. What excites you the most about the Perseverance rover?
Well, the Perseverance rover is going to do a lot of great science. So I'm excited, for example, that it's going to cache samples that we're going to bring back. Super excited that we're actually going to have samples from Mars in our hands. And I think that may clinch whether we can see that life is actually there. But I'm also super excited about Ingenuity, about the helicopter, which I got to visit out at JPL before it was strapped to the underbelly of the rover. And to think about flying a rotorcraft in, another world, essentially, in a place that only has 1/100th the Earth's atmosphere. It seems audacious, and I am impressed and amazed, and I can't wait to see if it works. I'm cautiously optimistic. I think the team is phenomenal.
And you did, in fact, a YouTube story on it, a piece on your channel, and did a fantastic job going to JPL.
I did, yeah, and I was just so lucky that it was like there, a meter or two away from me on the other side of a door in a clean room, and that was, one of the great moments of my life. Yeah,
that thing's going to Mars.
Exactly. Yeah, and it weighs like about as much as my laptop.
Yeah.
And you think about, it's substantial in its size, and it's going to go there and take off and fly all by itself, because of course we can't control it, given the time delay and everything. That is, I just think, one of the pinnacles of human engineering.
Yes, absolutely. Now, this is going to do some big science as well. What are your thoughts on the search for ancient microbial life on another planet, Mars?
Well, I think chances are good that Mars once harbored life. It was so similar to Earth in the past. One can only expect, life probably sprung up there as well. But I'm really excited for us to get that confirmation, because I think it really transforms our ideas about life and how frequent it is. Right now, all we have is this sample size of one Earth with life. If we find another one, that's 100% more information and data, and I think it's likely that life will not be exactly like ours. And I think it'll be fascinating, everything we can learn about other potential forms of life just by finding life on another planet.
You seem to suggest that you think there is life.
I do. I mean, you have liquid water for, I don't know how many, half a billion or a billion years. On Earth, that was enough to create life. So, the guess is that's not a unique thing, you know, right? I mean, the scientific hypothesis is you run that enough times, it's bound to lead to life again in other circumstances.
Dr. Derek Muller, we really appreciate you being here, YouTube creator with the channel Veritasium. We know you have a 2.5-week-old child your wife is holding down.
There are very few things that I could leave for. At this launch, that is one of them.
Thank you so much for doing so. Get a selfie with our full-size rover back here. You see
Yes,
that?
please.
I definitely will.
Very good. Thank you so much.
There has been a lot of anticipation by NASA teams leading up to this launch, but some won't be able to fully celebrate until the rover has safely landed on Mars 7 months from now. Raquel, you're there with the Mars mission team at JPL in California. How are they reacting to seeing Mars 2020 take flight?
Well, Moo, it's been quite an eventful morning with the earthquake, but you could feel the energy building in the room in the run-up to launch. And now I'm with Bobby Braun, the Director for Planetary Science at JPL. Bobby, now that we've started our journey to Mars, can you tell me how you are feeling?
Wow, it's a great day. We're all so excited, and to get started in this way and to be on our way after all this work that the team has gone through. It's really just fantastic.
That's great. Now that Perseverance is off the launch pad, what are its next steps?
Yeah, well, we're almost on the path to Mars, if you will. The launch vehicle has done great so far. Our partners at ULA are just fantastic, and we're very happy to be working with them and for them to give us this boost so far. But we still have to have another burn of our upper stage. We have to pass through the night side, or the shadow of the Earth, come out on the other side and find the sun and power up, and then establish contact with the spacecraft. And once we do, we'll truly be on our way to Mars. We'll have a spacecraft that's power safe, that we can communicate with, and our journey will really begin.
We look forward to that. Thanks, Bobby. Now, Daryl, as Bobby mentioned, there's an excitement here in the room as the team looks ahead to the second Centaur burn. But before we get to that, let's learn more about the science on board this rover.
All right, thanks, Raquel. And as you mentioned, there are numerous scientific studies and technology demonstrations on Perseverance. Some of these are directly preparing us to one day send humans to Mars. One in particular is called MOXIE. Jeff Sheehy from the Science and Technology Mission Directorate is joining us now to explain, and he is here with us. Sometimes here at the
difficulty with this technology
that's all right.
here, Daryl.
Well, that's all right. It's a Britney Spears style mic, So
like this.
I don't know if that'll work fine. We can hear you. Yeah. Thanks for making the adjustment there. So Jeff, this is an incredible piece of technology here, this MOXIE, right? So tell us, what is it and why is it important?
Well, MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. That's kind of a mouthful, so we grab a few letters out of there and just call it MOXIE. And I think the name MOXIE has a certain kind of attitude that's appropriate for this ambitious mission to Mars. But what in situ resource utilization is utilizing the resources that we find at a destination to produce useful commodities. And so what MOXIE is going to do is suck in the Mars atmosphere, which is mostly carbon dioxide, and produce pure oxygen. Oxygen is a commodity that we can use in our exploration endeavors. And so MOXIE is the first in situ resource utilization experiment on another planet.
How about that?
So that's why it's so important. If we can produce things we need at the destination, we don't have to load them in a launch vehicle, launch them from the surface to Earth, push them all the way to the destination and land them on Mars or the moon.
Saving incredible weight, fuel, resources to use them, the ones that are there and in place.
That's right. It took a lot of moxie. What were some of the biggest challenges in developing this technology, designing it, developing, building it?
Well, the team that produced the hardware that we just saw being launched on its way to Mars, they certainly had moxie because they had to overcome a lot of challenges along the way. When you start to develop new technologies, you're working in a laboratory and you've got all the room you need usually. You can build it big and heavy because you're not trying to make it look pretty, you're just trying to make it work, and you've got all the power you need, and you can control the thermal environment, and you can have teams of people come in and tinker with it and fix it when it breaks and all of that. So But, and you can probably see where I'm going with this, when you get to the point where it's time to fly that hardware to prove it out in the space environment or on the planetary surface, then the rubber really hits the road in terms of the engineering. And that's where the teams of engineers come into play, and they develop clever solutions to implement the process that's been developed in the lab and package it for space flight. So Moxie faced a lot of challenges. You know what? Once you have to put it on the rover, the size becomes important. It has to fit in a certain volume on the rover. The amount of weight or the mass becomes really important. Every ounce you launch into space takes propellant to move it. So we want to make Moxie as light as possible. Had to fit within a certain mass budget, or they would have kicked it off the rover.
Yeah, and we're glad you made it on the rover.
Yes.
And just real quick, and without getting too deep into the technical details, how does it convert carbon dioxide to oxygen?
So Moxie uses a thermal and electrochemical process. There's a compressor that was built by a company called Air Squared. Some of that was funded under the NASA Small Business Innovative Research Program, actually. And they built the compressor. What it does is acquire the carbon dioxide from the Mars atmosphere and push it into the electrolysis system. A company called Ceramatech, a team led by a guy named Joe Hartvigsen. They're now called Oxyon Energy, I think. But they built the guts of Moxie, which is the solid oxide electrolysis system that takes the carbon dioxide, CO2, actually pulls an atom of oxygen off the CO2, leaving CO.
Oh, wow.
And then those atoms migrate through the electrolysis system, and those oxygen ions are neutralized, and then they recombine. An O and an O becomes O2. And so we get pure oxygen out of the system.
That's fantastic. And so in order for you to get Moxie on board the rover, actually you had to kind of clear through the very smart lady to my left. She's with Planetary Protection. So she actually had to clean off part of it, right?
Yeah.
You had to heat it and then clean the
That's
O2
right.
sensor.
Yeah, the SOx part was actually self-sterilizing. It was hot enough so it cleaned itself. But there's a part, the O2 sensors, that needed vapor hydrogen peroxide sterilization. So it was the first time we used hydrogen peroxide on flight hardware.
Oh, that's awesome.
Yeah.
Yeah. So you can say thank you.
Thank you.
Thank you. No, thank you.
Appreciate it very
Thanks for
much.
letting us do that.
Well, you know, in speaking about the rover, Moo, what is it? You know, Curiosity told us that we have, or had at one time on Mars, moving water.
That's
So,
right.
so what is Perseverance going to do in terms of confirming whether life could have been there?
Yeah, exactly. So the past missions set up the stage as far as understanding what could sustain life, and now we're actually looking for signatures of that life.
And so some of the answers that you're looking for, which one are you personally looking most forward to?
Yeah, I'm personally looking forward to seeing signs of life where no one will argue that it has a biotic source. It's very easy to say, oh, this chemistry could have happened from natural reasons, but I want to see a smoking gun. It would be awesome to see that.
Now, that's not exactly easy, right?
No, not at all.
And so explain that to us.
Yeah, so in order to get that definitive signal, one of the main things you have to do is make sure you have a clean instrument that you're sampling with. And so that's why we spent a lot of time cleaning, baking out hardware to such a high degree, 150 degrees Celsius for some of these parts, to make sure it was clean enough.
And so those parts have to be specially made to be able to handle that heat.
That's right, yeah.
In order to get it past you.
Yeah, all of the material selection, everything was done specifically for that purpose.
Where else in the universe, Moo, do you think we should explore for life?
Yeah, I'm really excited about Europa. Europa has an ocean underneath a thick layer of ice. It has vents underneath that have a heat source, so there's a source of energy for possible life.
Europa, a moon.
Yes, the moon. Yeah, icy moons. That's the next place to go.
It's interesting that you picked that. I mean, it's a very, very cold place.
Yeah.
You've got a rover in front of you that is
I
miniaturized.
do.
We have one that is behind us.
Yeah.
Right? And as part of this, you also had to make sure that that nuclear battery was installed.
Exactly.
Yeah, there it is.
Yeah, this bit back here.
Tell me about how that worked, when you did it, and how that process was.
Yeah, it was only a few days before this launch day. I mean, we just finished counting our samples just a couple of days ago.
How about that?
Yeah, so we had to actually alter the way we sample. We take wipes and swabs of every surface of the rover. But for this, we had to make sure our head was far back and we had as minimal radiation impact as possible. But we got it. It was super clean. INL did a great job. Everyone has done a fantastic job. making sure this is as clean as possible.
It's ready to go. What do you think about that full-size rover behind us?
It's incredible. It's like,
Yeah.
hey, you should be up there.
And apparently it is right to scale as you take a shot of it there. That's a beautiful rover. Well,
it is.
thanks for describing all that to us, Moo. We
Yeah.
really appreciate the time
My pleasure.
for you describing that. All right, back into the show now we go. Moving forward, of course, this is the countdown as we go up. You can see the Centaur there in the graphics as we are tracking and continuing to track Mars 2020 on its way. And when searching for the possibility of life on Mars, it's all about location, location, location. And Perseverance's destination is a place called Jezero Crater. Let's go back out to JPL now. And Raquel, you've got a scientist there that believes Jezero Crater gives them the best chance of finding any evidence of past microscopic life.
That's right, Daryl. Knowing where to look for signs of ancient life on Mars can be a daunting task. It took 5 years to select a perfect landing site, and with us now is Katie Stack-Morgan, one of the project scientists who helped pick that location. Katie, can you tell us why we're heading to Jezero Crater?
Thanks, Raquel. There are many reasons why scientists are so excited to send Perseverance to Jezero Crater, and why we think that Jezero Crater is an ideal place to begin a Mars sample return campaign. At Jezero, we think that Perseverance can assemble a diverse set of samples that will help us resolve some of the most important questions about life beyond Earth and the evolution of planets over time. At Jezero, we know without a doubt that there was an ancient lake and river delta. And at Jezero, we have river valleys that flow into and out of the crater, and we know that that lake filled up with water and then overflowed. Life as we know it requires water to survive and thrive, and we think that Jezero has all the building blocks to support past life. At Jezero, we also have one of the best preserved deltas on the surface of Mars, and deltas in lake settings are ideal for supporting life. And the rocks that Perseverance will explore can tell us more about the possibility for past life on Mars. The rocks at Jezero Crater are also some of the oldest on Mars, between 3.5 and 4 billion years old, and that's the same interval of time when life was developing here on Earth. So by exploring the rocks in Jezero with Perseverance, we have the opportunity to explore more about the development of life in the solar system and can answer some of the major questions we have about that fundamental question. Back to you, Raquel.
Great. Thank you so much, Katie. And with that, let's head back to Kennedy Space Center. Daryl?
Much, Raquel. We are back here at the Kennedy Space Center with our most special guest, Moo, and the Perseverance rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Moo, here it is.
Yes.
And so we've learned a lot about this rover so far. So tell me, kind of describe from top to bottom what we're working here. At the top, you've got the mass cam, which is pretty tall, right?
It is very
it's
tall.
towering over your head. It is on a stage, but what does it do?
Yeah, so it has a lot of fun components. Some of them are the Mastcam Z. Z stands for zoom, so you see those two stereo cameras. And there's also that eyeball, what looks like an eye, is actually a laser. It shoots at the rocks.
A laser.
A laser, lasers. And then depending on the signature that comes back, the spectrometer reads it and tells you what the geology is.
And that's fantastic.
Yeah.
And some of the real exciting science, though, is happening right here on this part. This is the articulating arm that comes out, right, and then goes down onto the planet and starts drilling.
Exactly.
And what all is here that's going to help us understand more about the geology of Mars, the climate, and whether or not there was life?
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah, so
there's
show
a
that on the camera
3D
there.
printed tube here. And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, And there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes, Ingenuity.
This thing is going to be actually tucked up underneath the Rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions. Yeah. It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look
right.
At the blades.
Wow.
These blades turn, right? And they turn in opposite directions.
They do. They do.
It will have a camera on it. It will shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour.
Yeah.
The mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers. Believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
Launch commence. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Our collective perseverance is what has gotten us to this day, and now Mars 2020 is on its 7-month journey to Mars with an anticipated landing date of Perseverance on February 18th, 2021. Now we are joined by Dr. Thomas Zurbuchen, Associate Administrator for Science at NASA. Dr. Z, thank you so much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know, we have the space mission, and we're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn, but not quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really 2 pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction. Yeah. So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes you want to be right there so you can get captured. The second one, which is the one that's going to make us nervous in February, is to entry, descent, and land. So the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which is go in and with parachutes.
Yeah.
If there was none of them there, you could do, what we do at the moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other two. And so that's what makes it so hard.
Wow.
You've devoted much of your life to science. And I know you were asked the other day during a news conference, why another rover? And you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it. It's the next step, and of course there's others coming. Dragonfly.
Yeah.
We're already thinking about, and other missions. We want to, of course, go to Enceladus in Europa, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
So yeah, exactly.
Yeah, and so we want to do a social media question real quick, if that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions, to Mars, like Spirit, Opportunity, Curiosity, and Perseverance rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world. And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right? It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much.
Appreciate it. Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, so sorry, I'm being held. We're going to hang out here. So coming up, so talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yeah, so C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right. Thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. So we have so many great questions for you. Why are missions to Mars unique?
Well, I think they're unique for two ways. And one is just Mars. It's been in our imagination for centuries. It's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you can learn from your mistakes. You can learn from your successes. One of the things I like to joke about is, we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they, so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard?
They're hard because you can't really see what's going on. You can't use your human responses, right? You're used to driving your car and see what's happening, and you turn the wheel. In this case, we've got to tell the rover. We've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. So we talk to it once a day, and we say, how are you doing, and go over there and do these experiments, and then it's got to do that. So, we kind of give it its intention, but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah. Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. Our view is it's just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California.
Okay.
Maybe it's like hurricanes here or something, but there's tropical storms here. But it was a very minor event, and everything's fine. And we were on our way to Mars.
Okay. So a little rumble here in Florida, some rumble in California. It works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
Awesome. We will have that conversation, a conversation with Zena Cardman coming up, which I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA is focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done, and
we have main
engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together,
system is in
and
closed loop
as we're hearing, everything is looking nominal on this fire so far. Main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me.
Yes.
He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I work with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah, so a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, like, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean,
Very
how cool
good.
is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions. That's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the Commercial Crew Program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes,
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards Commercial Crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up and comings. You may have heard some, right?
It is
like
a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here, you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation, as you say, Nick.
Operation. We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on
The
data.
RL10 shutdown parameters
let's talk
look
about
good.
Communication for a minute, Nick,
And we're
because
seeing-
it is not an automatic thing to
So
just
you're seeing,
shoot
current
information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think.
Yeah.
Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions. But, of course, in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes, of like we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want, and we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
So
and Josh, we heard
I'm just
Jesse
going to
telling
give
us that
a
Centaur
quick
is,
reference
spinning up.
about what Tropical Storm Isaias ECAS
where we get into a
is
slight
going
to give Mars 2020 some
Centaur tank pressure
stability.
I will be doing a real video, but the maximum sustainment of 60 miles per hour is moving northwest at 20 miles per hour, 17.6 north, 68.5 west. This is intermediate advisory
operations. They need the rolling activities, as Mick's saying. It's basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually.
And we have successful separation of Mars 2020 with the Perseverance rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant. We're hoping we'll get to see that here in a few minutes. We'll bring that to you if we
what
do.
just happened
But tell us
was
about
the
separation
Mars
maneuver,
Perseverance
because the
rover that you
apparatus,
just saw
the
that
actual-
just shot
it's
off
really simple
is
design.
now going away
We'll
from
talk about it in a
the
minute, but
booster,
you
which
see right now,
is
you see
very
the,
good.
Mission Director Center where Omar Baez and the team are, and Josh, you and I
But
talked about this
now
a little
talking
bit earlier,
back to Tropical
but
Storm
with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
It's actually forecasted to now move
Centaur will now perform its standard propellant blowdown
east
sequence to
of
alert the vehicle
Florida,
and complete today's
but it
flight
could just keep
after
wobbling
completing
back and
its,
forth.
its CCAM avoidance
And
maneuver. This will conclude
possible
today's commentary of the
landfall
Mars 2020
in
mission.
Dominican
This is
Republic
Atlas
is
Flight
going to
Commentary signing
happen.
So that's
But
the end of
if
ULA's
it makes
job for
landfall
today.
in
Jesse Gonzalez did a great
Dominican
job with ULA
Republic
Congress
or Haiti,
What I was saying about
if
the
it
Mission
makes
Director
landfall in
Center is
Haiti, it will
normally we would see a
dissipate.
lot of
If it
clapping,
makes
a lot of
landfall
applause, a lot of
in
high-fives,
Dominican
high-fives, yeah.
Republic,
But with the
then it'll
pandemic and everything,
stay a
people are
lot.
staying their distance, taking the guidelines.
So it's 125 miles west of Puerto Rico, about 105 miles southeast of Santo
work to get to this point, and
Domingo, Santo Domingo, Dominican Republic.
And on top of all that, 2020
A
was
tropical
like,
storm warning is in effect
so
for
it's
Puerto
just-
Rico via
we did it.
Cruz
Like,
and
we're
Puebla
most of the way there,
and
not there yet. Yeah, as you heard Omar earlier in the
Puebla,
broadcast say, a
U.S.
lot of
Virgin
those, when we
Islands,
started
British
this,
Virgin
when the
Islands,
pandemic started,
Dominican
we
Republic,
kinda
entire
thought
southern
Mars
and
2020 might
northern
be Mars
coastline,
2022. Yeah.
north
But,
coast of
Mr.
Haiti,
Bridenstine and the
from
NASA agency decided to
Elmore
move forward. The
St.
teams
Nicholas
found ways to do
eastward
this. As
to
we heard,
northern
they were
border
disciplined,
with
they
the
were focused, they were
Dominican
courageous.
Republic,
And,
Turks and Caicos
all that played
Island,
off today with a successful
southeast
launch
from
of 750,
Bahamas,
and now
including
spacecraft
Acklins,
separation,
Crooked
Mars 2020,
Island,
Perseverance,
Long
and Ingenuity
Cay,
on their way
Inaguas,
on this planet.
Hey,
Maya
we're getting ready for
Guana,
acquisition of signals. Stay
and
with
the
us.
Ragged
But really
Islands,
fast, Nick, tell
Central
us very, very
Bahamas,
quickly about
including
this
Cat Island,
mechanism.
Exumas, Long Island, Rumkey, and San Salvador. A tropical storm watch is in effect for northwestern Bahamas, including Andros Island, New Providence,
some spring systems in it that once the signal is sent,
Abacos Island, Berry Island, Grand Bahamas Island, and Bimini.
force to push the spacecraft off the front.
The next advisory is at 11
And again,
a.m.
hopefully we'll see that
AST,
video here
also known
momentarily,
as 11
but for now,
a.m.
we're going to send it back to you and check in for one final time in a little bit with the folks
Okay,
here
let's
at
just
ASOC.
keep listening.
But Daryl, back to you.
All right, thank you, and great job, both of you, Joshua and Mick. It's always great to see Mick explain that springs are what's getting us to Mars. All right, so we've got our second burn underway. We've been flying for right about an hour, and as you just saw, space spacecraft separation went well, and so that's fantastic. We can now say that Perseverance is officially on its way to Mars.
What a beautiful thought that is. And while NASA has been tracking the spacecraft since launch with its tracking and data relay satellite system, I know the mission control team at JPL is turning their attention to the next milestone, and that is ensuring that the array of communication antennas known as the Deep Space Network, or DSN, begin to receive a signal from the spacecraft flying the Perseverance rover to Mars. We expect to see the teams acquire the signal close to 9:14 Eastern Time. Though, as you saw, the spacecraft separation has occurred in the shadow of the Earth and out of line of sight of the system, so this could take a bit longer than estimated.
All right, and so finding life on Mars won't be as easy as you might think, and we talked a little bit about that. Here to talk about that and more is NASA